Welcome to the 11th video in the SaaS SCADA configuration training series. The project works well with the basic settings, but there are extra features and configurations that can be added. This video will cover two of four configurations, interlocking and topology. Interlocking configuration. The interlock functionality determines the interlock conditions of the equipment, which block the control buttons and the control windows. The configuration of this feature is divided into two parts, defining which equipment has interlocking logic and registration of the equipment's operation conditions. Definition of equipment. To define the equipment with interlock logic, it is necessary to access the bay templates with the suffix sta. In each template, identify the equipment that can be controlled by ActionNet. Find the corresponding tag with the suffix interlock, and in the command column, enter the value that the equipment assumes in the off or open state. Logic registration. To register the operation conditions of the equipment, it's necessary to configure the file responsible for the interlocking functionality in the project directory. It contains information regarding the equipment to be operated and the operation conditions. For example, the conditions for opening and closing the Bay 201 circuit breaker are equipment in remote mode and remote bay and without active lockout. We can have a better understanding by opening the file in Excel. The configurations are divided into two parts: data of the equipment to be commanded and operation conditions. Bay, name of the bay as registered in the object table, in the format level\object. Equipment, name of the equipment as registered in the bay states template. Action, operation to be performed on the equipment on or off. Tag is a tag associated with the condition that will be evaluated. Normal value, normal or expected value for the condition being evaluated. Description, optional field used to define a custom description instead of the one registered in the object table. IsDesk, this field is used to define which description will be displayed. When the value is set to 0, the system uses only the description of the registered tag. If the value is set to 1, it combines the description of the registered tag with the description provided in the description column. And finally, when the value is set to 2, only the description provided in the description column is displayed. Is/or. This field defines the logical operation between the current condition and the next one. When the value is set to 1, the conditions are evaluated using an OR operation. When the value is set to 0, the conditions are evaluated using an AND operation. With the project active, it's possible to see how this interlocking occurs by opening the control screen of the circuit breaker in Bay 201 configured in the file. On the screen shown, you can see that the control buttons are locked. Clicking on this button, the conditions causing the interlock will be displayed. It's noticeable that the remote local variables for both the equipment and the bay aren't meeting the interlock conditions, while the lockout is complying with the imposed condition. To release the control buttons, all interlock conditions must be met. We can simulate the following values. With all conditions met, it's now possible to send the commands. Topology configuration. The topology in substations considers that each object in the database corresponds to a bay. Internally, this bay has power supply routes that need to be defined based on its connecting elements. Externally, it can be connected to other bays. For those with connections to 3 buses, it's necessary to create auxiliary bays and associate them with their respective auxiliary templates. When the imported database doesn't contain the buses, these must be created manually using the appropriate templates as shown. It's time to configure the so-called topology matrix that defines the interconnections between the substation bays. To configure it, we'll use the extension Topology Generator. Now, for each single line diagram, select the name of the screen corresponding to the diagram and the level at which the bays are located. Define the supply base for the selected single diagram. That is, the base that defines the start of the power supply for the single line diagram on the screen, and then click on Edit. The interconnections are defined in the topology matrix. The rows represent the sources of the connection, and the columns represent the destinations. The line base connects to the bus bars. Connect each of its routes to its respective bus bar. Main routes of the line base are connected to the main bus bar, the main bus 1. Alternate routes are connected to the alternative bus bar, the main bus 2. Auxiliary routes are connected to the auxiliary bus bar, transfer bus. The bus bars are connected to the transformer following the same logic of main, alternative, and auxiliary. After completing all connections, click Save Matrix. For 33 kV single line diagram, follow the same procedure. Connect the incomer to the bus 1 bar, and this bar must be connected to the feeders. Attention! Topology matrix settings are loaded into memory during project initialization, so after any changes are made, the project must be initialized again. Now we need to configure the template settings, which will define the general topology settings in the template ZLA topology parameters. To do this, we need to open the Templates tab and look for the configuration template. Activate the columns Start Value and Comment. In the configuration that indicates the names of the configured auxiliary base, write their names in the comment, separating them with a semicolon. In the configuration that indicates which are the independent supplier base, write the names of these bays in the comments, following the structure level and the name of the supplier bay. Separate by a semicolon if there are other supply bays. In the configuration that indicates the minimum voltage value for the bus bar to be considered energized, define the initial voltage that should be considered. In the configuration that indicates what are the dependent supplier bays, write the names of these bays in the comments, following this structure, level and name of the base supplier, column the power source for it, or the sources. It's important to note that a dependent supplier bay occurs commonly when one single line diagram communicates with another on different screens. Finally, we must do the screen settings, where the proper configuration of the symbols on the single line diagram screen will be done. To do this, we must open the Draw module. Also, edit the newly created tags in the line base. Now, let's edit the 33 kV screen, adding the low voltage bus bar. This video presented additional interlocking and topology configurations. In the next video, we will conclude this training by discussing additional template and alarm settings. See you then, thanks for watching.